Okay, today's lesson is about factoring difference of squares. All right, so the first thing I'm going to do is refresh your memory on some multiplying binomials that we have done before. As you remember, if each term in the two binomials is actually the same, but we have different signs, we can actually just square, and put a minus. So this is going to be two blanks. This will be x squared when you square it. If you square 3, you get 9, and we put a minus. Okay, so let's look at the next one. So each term, basically the first two terms are the same, the last terms are the same. We have a positive, we have a negative. We know it's going to be two blanks. We're never going to have a minus. You're going to square the x and get an x squared. You're going to square the 10 and get a 100. Okay, so what we're going to do today is we're going to start with x squared minus 9. And we're going to come up with x plus 3 and x minus 3. That kind of process. Okay, so the first thing that you always do is we're going to look for common factors first on every single one that we ever factor. The best thing to do is to look for common factors first. All right, now I need to also go over the list of perfect squares. All right, now we haven't made one of these yet, but I thought we would do that now. So we will have, if you get the first perfect square, 1 squared is just 1. 2 squared is just 4. 3 squared is just 9. 4 squared is 16. 5 squared, 25. And you can keep going and going and going. So I'm going to just list some. I think I'll list them up just a little ways. All right, so the next one would be 36. And then you would have 49. 8 squared would be 64. 9 squared would be 81. 10 squared would be 100. 11 squared would be 121. 12 squared, 144. 13 squared, 169. 14 squared, 196. 15 squared, 225. And this just keeps going and going and going and going and going. And I think that you will probably have to use at least up until 225, but I think you also may have to know some bigger ones. So it's probably to your advantage to practice making these up pretty far, maybe up to like maybe 20 squared, or even bigger than that, 25 squared, or even more than that. So that you could just go ahead and keep making a list and just keep going up for a little while. You're just going to have to learn how to recognize most of these. And if you're going to use your calculator, you just do the square root of whatever number that you get and see if it's a perfect square. But this will just give you something to go by if you want to kind of keep these in your head and make it go a little quicker. All right. After you look for common factors, then of course we're talking about a binomial. So we're talking about x squared minus 9 or x squared minus 100. So we're going to be looking for a difference of squares, and so that means first of all it has to be a binomial. Okay, so of course you know that bi means 2, so that's going to be 2 terms. All right, well, what else will we look for? We're going to also look for a minus sign. Okay, as you noticed when we multiplied those, we have a minus sign for each. And then the last thing that you have to have is each term has to be a perfect square. So each term has to be a perfect square. And what is a perfect square again? It's one of those numbers that we just came up with. Okay, so each term has to be a perfect square. Okay, so we're just going to start with, let's start with the x squared minus 9 that we had just a minute ago. So I'm going to just go over x squared minus 9 real quick, just to show you how we come up with x plus 3 and x minus 3. All right, so the first thing that you would look for on this, and this came from the example at the top of the page, is it's a binomial. And you would look for common factors, okay? So is there a greatest common factor? Well, this is a 1 and this is a 9, so no, there's not a greatest common factor. There's not an X in both, so we don't really have to worry about that one. Okay, then you're going to look to see if, since it's a binomial, does it have a minus sign? Yes, it has a minus sign. All right, the third thing that we would need to know is, would each term be a perfect square? Okay, so we have x squared, and anytime you have an even exponent, you know that it's a perfect square. So let's write that. Even exponents are perfect squares. All right, so you probably want to write that on your paper somewhere. Okay, and 9 is a perfect square because 3 times 3 is 9. So that's a perfect square. All right, so if we have a minus and if we have 2 perfect squares, then this is going to turn into 2 parentheses. All right, what do you square to get x squared? Well, if you have x and you multiply it by x, you get x squared. And what do you square to get 9? Well, you square 3. So the square root of 9 is 3. All right, now, in order for that middle term to be canceled out, and we've talked about this before, this has to be a positive 3, and this will have to be a negative 3. So then all you have to do is check and make sure you're correct. So we know from experience, x times x is x squared. X times negative 3 is negative 3x. 3 times x is 3x. 3 times negative 3 is negative 9. Now the negative 3x and the positive 3x is going to cancel out, so we're left with x squared minus 9. Okay, so this would actually just be square, square, put a minus, which is how we used to do it, how we did it in class. Okay, so that's how we would have done the 2 at the top. So now let's go on to number 4. All right, number 4 says m squared minus 81. Okay, so first thing I'm going to look for is common factors. All right, so let me see. No, there's not a common factor. All right, so we look for common factors, but that's a no. All right, so the next thing is it's a binomial. Notice I didn't even say, oh, we have a binomial, blah, blah, blah. I said look for the common factor first. Then our decision is, now it's a binomial, so what am I going to do? Well, right now, the only other thing except for common factors that I know to do with the binomial is check for perfect squares and a minus. Okay, so here we go. We have perfect square here because that's an even exponent. I know that 9 times 9 is 81, so that's a perfect square. And I have a minus. So automatic, right, 2 parentheses. I squared m to get m squared, so this is going to be m times m. And the square root of 81 is 9. And of course, for the middle terms to cancel out, you use a positive and a negative. So this would be the shortcut, which you would square the m, get m squared, square the 9, get 81, and put a minus. So I know that checks. All right, number 5. Okay, again, look for common factors. So common factors, what would they be? Well, I don't know of anything that'll go into 9 and 49. Okay, so they don't have a common factor. A is not in both, so we don't have a common factor. All right, so now we're going to check for perfect squares, where I know that the square root of 9 is 3. I know that this is a perfect square because it's an even exponent. I know that the square root of 49 is 7, and this is a minus sign. Okay, so I'm going to automatically write my 2 parentheses. Square root of 9a squared would be a 3a. The square root of 49 would be a 7. And my signs are going to be a positive and a negative. So it would be square, square, put a minus. So we square this, we get a 9 and an a squared. We square 7, we get a 49, we put a minus, and that would check. All right, so let's move on to number 6. Do we have any common factors? No. There's nothing that goes into 4 and 9, so we don't have a common factor. All right, do we have perfect squares? Yes, that's a perfect square because the square root would be 2. That's a perfect square because it's an even exponent. That's a perfect square because the square root would be 3. Do we have a minus? Yes. So I've checked I've checked both of those things, minuses and perfect squares, and we had yes on everything. So 2 parentheses, square root of this will be a 2 and an x. Square root of 9 would be a 3. Positive, negative. What do you get? You square the 2x, you get 4x squared. You square the 3, you get 9, you put a minus. All right, look at number 7. Does it have a common factor? No, that one doesn't have a common factor either. Okay, so let's check and see if they're perfect squares. Yes, they're perfect squares, but look what this is. That's a plus and not a minus. It's not a minus. So if you don't have common factors and you don't have a minus, but you did have perfect squares, then there's really nothing else you can do. These are squares and they're not cubes. And we will learn another rule about perfect cubes in another lesson. So on this problem, you can't do anything else. So this would be called prime. So that's a prime polynomial because you can't factor. Okay? This is not a perfect square. And later on, we would look for perfect cubes. This is also not a perfect cube. Neither one of those. Okay, so that's how you do difference of squares. All right, now we wrote the rules on the other page, so I'm not going to worry about writing all that again. So I'll just scratch that out. You've got the rules. I think we're on the same page that you had. So we're going to just automatically, we're going to start looking at these. And I've called this difference of squares, but we also have to make sure that that's the case. All right, so these are some harder problems because they have some common factors. They have exponents other than even exponents. So we'll just have to look and see what we have to do with these. Okay, so the first thing, of course, in a factoring problem, just like I said before, is to check for common factors. Okay, well, I see that 2 would be a common factor for 2 and 32. So I'm going to make my cloud, and I know that we have a common factor of 2. There's not an x in both, so I don't have a common factor for the x. So we already know how to factor out a common factor, so I'm going to write that 2. I'm going to put a parentheses. There's 2 terms, parentheses. Okay, now this is a minus sign, so at our experience with common factors is all you're going to do is take this and divide 2 into this, so that would kind of cancel out. That would leave you with x to the 4th, and then divide 2 into negative 32, and that'll give you that 16. Okay, now you're going to want to stop right here, but you can't stop now because we know that we have to look for other things now. We're not just doing common factors. You're doing common factors and difference of squares. So now you're going to check to see if the part that you have in the parentheses is a difference of squares. Well, we have a minus sign, and we have an even exponent on the x, and I know that the square root of 16 is 4. So, yes, I do have a difference of squares. So this is going to turn into 2 different parentheses. Once I write these 2 parentheses, I don't have this one anymore. I'm going to actually just mark it out because this is going to turn into 2 parentheses. All right, now you're just going to carry that 2 down in front of it. Okay, so we've talked about this before. If you take the square root of an even exponent, all you have to do is divide it by 2. So you're just halving it. So the square root of x to the 4th is x squared. All right, what's the square root of 16? Well, it's just 4. Now the rule says you have to put a plus and a minus. Okay, all right, so that's going to be how you would factor x to the 4th minus 16. Okay, so instead of stopping here though, I still see squares. I see a square on that x, a square on that x, and I think that 4 is a perfect square. Well, if you do the square root of 4, of course, you get 2. Now, the rule says it has to be 2 perfect squares and a minus. So I actually can't do anything else to this one that has the plus sign. So I'm going to write that 2 down. I'm going to write that x squared plus 4. Okay, now I told you a minute ago that I was going to cross this out. So I'm going to just kind of put a mark through that because I don't have it anymore. All right, now if you look at this one, you've got a square, and you've got a square, and you've got a minus. So this is actually going to turn into 2 parentheses. So you're going to put 2 more parentheses. And you're going to say, wow, that's going to be a big answer. Well, it is, but you have to factor completely. So the x squared is going to turn into an x. The 4 is going to turn into a 2. And the minus, of course, turns into a positive and a negative. Okay, so since I turned this parentheses into 2 other parentheses, I'm going to mark that out because I'm not using that anymore. And this one came here, so I'm just going to mark that out too since I moved it down. Okay, so it looks like the only one you have to check when you get to this point would be everything that's got a minus. So let's see. That's a minus, but that's not a square. Neither is that. So if one of them's not a square, then you can't do anything else. So this is a big answer, but this is how you factor that little bitty problem that we started with. Okay? All right, so now let's move to number 5. All right, so number 5, we're going to look for the greatest common factor first. Okay, so what goes into 20 and 125? Okay, so if you figure that out, it's going to be a 5. So the common factor or greatest common factor is going to be a 5. All right, is there, since there's letters here, is there a C in both? Yes, there's a C in both. Now you remember from experience, you bring out the smaller exponent. So it's going to be C to the first. Is there a D in both? No. So our greatest common factor is 5C. So the first thing I have to do is 5C, and I have to write a parentheses with 2 blanks. This is a minus, so I'll put a minus. And now I'm going to fill up the 2 blanks. Okay, 5 goes into 20 how many times? 4 times. This C and this C would just cancel out, and then I would have to put a D squared here. Now look at that. That's a square now. We have a perfect square and a perfect square. All right, 5 goes into 125, 25 times. Remember, that's 5 quarters is 125. C and C to the 5th. All right, that'll be 5 minus 1, which would be C to the 4th. So I'm going to write C to the 4th. Well, 25 is a square, and so is C to the 4th because it's an even exponent. And we have a minus. So this is going to turn into 2 other parentheses. So we'll still have the 5C. I'm going to write my 2 new parentheses, and this is going to actually change to these 2 things. So we actually won't have this anymore. So the square root of 4 is 2. Square root of D squared is just D. The square root of 25 is 5. The square root of C to the 4th is C squared, just half it. And then 1, of course, is going to be a plus, and 1 is going to be a minus. Okay, so from the experience on the other problem, you have to go directly to the one that's got the minus and see if it has perfect squares. Well, automatically, I don't see a square on the D, and I know that 2 is not a perfect square, and neither is 5. So I'm finished with my problem. So that one turned into these 2, so I don't have that anymore. So this is my answer. Okay, let's go to number 6. All right, so number 6. Okay, so we're looking for common factors. Well, this time there isn't a common factor. So common factors would be no on this. All right, I have a minus, I have even exponents, and the square root of 81 I know is 9. So I do have perfect squares. So right now this is going to turn into 2 parentheses. The square root of a to the 4th is going to be a squared, just half it. Square root of 81 is a 9. The square root of b to the 8th, half that, and you get b to the 4th. 1 is a plus, 1 is a minus. Okay, so I have one that's got a minus, so I need to check and see if I still have perfect squares. All right, that's a perfect square. That's a perfect square. And I know that 3 times 3 is 9, and that's a minus. So this is actually going to turn into 2 more parentheses. So this one is a squared plus 9b to the 4th. That is not going to change. All right, a squared minus 9b to the 4th is going to change. Square root of a squared, just half the 2, will be an a. Square root of 9 is a 3. Square root of b to the 4th, half it, you get b squared. And then, of course, one's a plus and one's a minus. I go to the minus, check and see if I can do anything else, and I can't because these are not all perfect squares. So my answer is this here, and not that. All right, the last one on this 5-minute check. You could try it before, you could pause it actually and try it, and then you could see if you get it right. So if you want to pause it, go ahead and pause it. Try the problem. And then turn it back on, and you can see if you got it right. Okay, so hopefully you did pause it. And I'm going to go ahead and look to see if we have common factors. Well, we don't. This is 2 terms. We do have perfect squares on the letters, but the 49 is a 7, and this would be a minus, so I know that's going to be p plus 7q, p minus 7q. I check to see if I can do the minus again. I cannot because nothing is a perfect square, and that would be the answer. Okay. So I've done difference of squares, and I think you have 2 or 3 more left on that paper, and I would like for you to try 8, 9, and 10 on your own. The next video is going to be perfect square trinomials, and that's the next one that you have to have done for class.